Now, step three, we begin to imagine a couple alignment scenarios. Now, you can imagine that, well, I'm going back to this visualization here. There are lots of people, there are a fair number of people who live in this area, and there are also people who are concerned about maybe the environmental integrity of this project overall. So there are interest groups who maybe want to optimize biodiversity. There may be another interest group representing some of the residents in the area that want to improve, like optimize the aesthetics of this project, given that you're going to have some power lines, high voltage lines running potentially right through your neighborhood, and up and disrupting maybe some of your views, some of the vistas that you've don't want again like disrupted in any way. So there are lots of maybe political and environmental and socioeconomic implications of this transmission line. So the challenge for you as a consultant, GIS consultant on this project, is to create some visualizations based on some grounded data, uh, that are, based on optimizing some characteristic or some theme. So what we're going to do is I'm going to go back to the instructions here and download our exercise for PowerPoint. So I'll click the link here, download the PowerPoint presentation, and let's walk through kind of the methodology again of this project, of this exercise, and then also start to build out one of the scenarios as an example. So the methodology will use some these data sets that we've already downloaded. We have the study area boundary, the origin station, which we also call the line source, and the line destination station. But then there are these other input data like earthquake. We have earthquake fault lines. We have roads within our study area. We have a biodiversity ranking of the area, a fire hazard data set, which ranks the area in terms of fire hazard risk. We have elevation information for the study area and also the population location. So all of these data, you know, you have available to inform the scenarios. And what we're going to do is create two scenarios. I'm going to go over just one as an example. Um, and what you need to do initially is just select uh, three data sets that you want, three raw data sets that you want to inform that are relevant to a particular scenario. So for example, in one I'm thinking of here is a scenario that maximizes cost efficiency. And I'll talk a little bit more about that. But what we're going to do is select a few data sets. Uh, we'll transform them in a way that they have a standard value range. We'll discuss why we need to do this, but they'll have a value range of 1 to 10, such that 10 represent less desirable areas. So we're going to make sure we transform all these data, if they're not already, into a raster data set, and we'll have a range of 1 to 10 in terms of values. And then we'll prioritize and sum the weighted data layers in order to create a cost grid and a cost distance raster that's used to inform kind of systematically this least cost alignment between the origin and destination power stations. Now, I know that that is kind of a lot to wrap your head around, but as we walk through, it'll begin to make more sense. So anyway, in your first scenario, what I want you to do is think about what you'd like to maximize or minimize. In this case, I want to um, maximize cost efficiency or minimize costs, you could say. what data sets do I want to use? I'm thinking I want to use the elevation data set as one of my raw data layers. Reason being, I'm going to use the elevation to compute slope, and uh, the idea is that you want to avoid uh, kind of dramatic or high, you know, variations in slope in order to minimize construction costs, like uh, constructing a transmission line along a very steep cliff, for example, would be very expensive and maybe requires some kind of heroic engineering. We want to avoid that, and so we want relatively kind of maximize um, uh, more even terrain. So we'll use elevation for doing that. Another one I was thinking of, use the roads data, uh, and kind of what we wanted is this the alignment to be closer to road infrastructure, and the idea being that maybe we could some of that land would there's probably is publicly owned, so we wouldn't have to worry so much about acquiring private property along the roads, and also by having the transmission lines around along the roads, we would be minimizing maintenance costs because we'd be able to easily access them. So we'll use the roads data set as our second layer. Another data layer I was thinking of would be useful to or relevant to cost efficiency would be fire hazard. The fire hazard data set, you know, in order to minimize long-term costs, we'd want to um, not have the power lines be in a high fire risk area. The idea we could start a forest fire or and damage some of the infrastructure as well as creating, you know, ecological havoc by creating the forest fire. So those are the three layers I'm going to use as the raw data sets. In our description here, what I would like you to do is kind of describe that rationale, you know, why you chose the three layers you selected, how they are relevant to your optimal scenario. So this is just one example. I provide a few more example in the instructions. Um, you know, and as I mentioned, you could, you know, think about biodiversity, or you could think about public safety, other sorts of things, but I'm just running through this one notion. Um, okay, so that's really it for step three is to start imagining a scenario and select a few raw data sets to inform that scenario.